So we're here at Dell Storage Forum in Boston, 2012, and I'm here with Koning from EqualLogic, and kind of wanted to talk a little bit about where you came from and the rise of EqualLogic and how that transition happened. So why don't we start off? How did you start off coming to EqualLogic?
Well, I'm one of the three founders of EqualLogic, along with my colleagues Peter Hayden and Paula Long. All three of us had worked at Digital in various places, and I had worked with Peter, and Peter had worked with Paula, although the three of us had worked together. In 2000, the three of us ended up together at this startup that was trying to build web acceleration technology, and was looking for money just as the bubble burst, so that didn't go anywhere. And we decided that we really enjoyed working together and wanted to make a try at building something that actually was a successful company. And so we decided that instead of building something that was based on the latest fads and bubble type of efforts, it should be something that bread and butter IT technology solves a problem that everybody needs to have solved, a problem that gets worse and worse every day for a large number of people. And also, of course, something that we understood and felt we had something that we could contribute. So after a little bit of digging, we realized that storage area networks was a place where that was the case.
And that wasn't, did you guys have that background before you started working on that problem?
To some extent. Peter had worked in a startup that built rate controllers that was sold to, I believe, Seagate, and had gone off and looked at some other possible ideas for startups that didn't come together. Paula had experience in operating systems and databases, and my professional background is largely in distributed systems, networks, protocol design, those kind of things. So when we started looking into it, we realized that those building blocks were exactly the building blocks you needed to come up with a new solution to an existing problem. And specifically, we looked and we said the problem with storage is it keeps growing. And because it keeps growing, you buy some amount of hardware to offer you some amount of storage. Right. And then after a while, you realize it's not enough.
Right.
So you buy more. Now what you have in a classical storage system is two islands.
Sure.
So you have an island that's full and an island that's empty. And the first thing you have to do is you have to take half of the stuff that's on the full island, shut down the applications that talk to it, pick it up and move it to the new island, reconfigure all the applications to look for the storage in a different place, and then turn it all back on. So you're looking at lots and lots of clobbered weekends.
Yep. You're
looking at coming in bleary-eyed on Monday morning hoping you didn't mess something up.
Right.
So we said, in a network, when the network needs to grow, you just plug in more hardware and it all works together as a single collaborating object that sorts everything out by itself.
Right.
And my experience basically was building the technology that does that. So we said to ourselves, can we do to storage what previously has been done to networks, make it for seamless growth, so that it isn't just the first time you buy a sandbox that you're happy, but when you buy 5 or 10, you're still happy because your job is getting harder and harder and harder.
Right, and I think when you talk about being happy, one thing that was clear is that you guys seem to focus on the user experience a lot.
Precisely. And so we realized fairly quickly that focusing on the complexity of growing storage was really just a single example of a bigger problem. The bigger problem really is that in 2001, managing storage area network was a very complex job. Sure. And you had to deal with strange technology, fiber channel, that only a small number of people understood. You had to deal, of course, with expensive hardware. But the biggest problem was really you had to manage a lot and lots of details. So, for example, if you allocate storage to an application, you didn't just say, I need this much.
Right.
You also had to say, which disk drives in this sandbox are you going to assign to that application? And what RAID type are you going to impose on those disk drives? And if you got it wrong, you'd have to do some major hassles to straighten it out.
No matter how big or small the organization, if you're one guy building, maintaining the IT infrastructure, you had to have the same skill set as a team of storage engineers at a large enterprise.
Exactly right. And what that meant in practice is that only large companies with large staffs that could afford specialists were in fact able to deploy a SAN. One thing we discovered early on when we went to talk to some of the companies that the VCs pointed us to vet our proposal is that when you could walk into their data center, they would tell you we have, say, 2,000 servers, and about a third of the storage used by those servers is on our fiber channel SAN arrays. And we said, oh, that's very interesting. And what do you do for storage for the remainder? They said, oh, it's direct attached. I said, oh, really? Why is it not on your storage arrays? Because obviously you don't need to have explained to you why a SAN is a good thing.
Right.
And he said, oh, no, of course not. But the problem is that the cost of implementing that storage on the set is so high that we can't afford it for those applications because the nature of the data does not justify the expense. And we said, aha. So in fact, what we really are going to be doing is not just a SAN for branch offices, which is sort of where we started, but really a SAN for the rest of us. A SAN for all of you who thought you wanted a SAN but couldn't afford it, or a SAN for those of you who have it but want it for the rest of your data. A SAN that doesn't cost a fortune to buy, and most importantly, doesn't cost a fortune to keep running.
You guys work for the other 99%, right? Not for the 1%.
That's sort of, I suppose, the contemporary way of putting it,
Exactly.
yes. But certainly one of the slogans we used is SAN for the rest of us.
And so your decision to, you guys really narrowed in on using iSCSI and IP, and you mentioned some of the reasons, but I mean, it seemed like you figured out how to get to, you figured out the right formula to serve a very specific market very well. Can you talk a little bit about, so there's ease of management storage and a little bit around the network cost, but what was that progression like when you guys started to show this stuff to customers and sell?
So one of the challenges at that time was iSCSI had been a standard that was under development when we started. It was not yet finished. And a number of the people who were pushing iSCSI were incumbents in the SAN business. And they were basically positioning iSCSI as the low-end, cheap storage, low performance, probably not even very reliable, but the stuff that doesn't really matter.
Treated worse than NAS, you would almost say, right?
Almost.
Almost, right.
And so we looked at that and said, you know what, if they want if those companies want to position it that way because they're worried about eating into their margins on their expensive fiber channel-based technology, fine, that's their privilege, but that's actually not an inherent restriction of the technology.
Right.
One of the things I had learned doing Ethernet and TCP/IP and various other things for 20, 30 years was that if you bet against Ethernet, you're in trouble.
Yeah.
It just won't work. You can't bet against Ethernet and succeed. And anybody who thinks that TCP is slow is confusing a poor TCP implementation with the inherent properties of TCP.
Right.
TCP, in fact, is as fast as any other network transport when implemented with equal levels of competence.
Sure.
And so that's how we looked at it. We said, iSCSI is basically SCSI over TCP instead of SCSI over fiber channel. So the application protocol, which is block access through SCSI, is the same. Only the transport is different, the wire is different. Those wires can be just as fast as fiber channel, but they will be a whole lot more cost effective because you don't need to build a separate switching infrastructure. You don't need to find the rare experts who actually understand the networking technology. If you wear an IT hat, you know about Ethernet. It comes with the hat. Mm-hmm. And so if we were aiming at supporting smaller companies, smaller organizations, we needed to tie into the experience of the expertise they already have. That expertise is TCP and Ethernet.
Did you find cases, since the technology was so easy to use, very low cost, easy to integrate with existing things, did you find circumstances where you did get the people who didn't know what they were doing and they would put the storage traffic on the same networks as the server traffic and kind of run into those things? And was that a challenge, and how did you guys address that?
I think we probably ran into some cases like that. But one of the things that you discover is we set out to build an array with good performance, not the very highest performance you could buy, because that means lots of money, but very competitive performance. And what we discovered was that in the real world, a large fraction of our customers are not at all stressing the array. So in fact, we have, first of all, of course, we have a number of documents that describe best practices, and we talk about both for reasons of separating traffic and managing traffic, and also for reasons of security. Our best practice is that you have the server LAN and the iSCSI SAN are distinct networks, with just a filtering firewall in between for the management access to operating. But realistically, a lot of our customers could disregard that advice, and for, at least from a performance point of view, have perfectly acceptable performance.
It's almost like driving a race car, and you really don't necessarily know how to drive the race car, but unless you push that race car to its fullest potential, you don't necessarily notice maybe these edge case implementation.
Precisely.
There's a lot of forgiveness.
Yeah.
Right?
If you go commuting in a Porsche, it's a perfectly nice commuting car. It will also entertain you around the racetrack if that's what you want to do on the weekends.
Yeah.
So the other thing that we did in setting up our support organization, and I'm not sure that we ever explicitly said it in so many words, maybe we did, is our support organization built a reputation of being the people that never point fingers somewhere else. And our customers say this over and over, and they're very happy about it. Basically, we felt it was our job, and as a startup, you really have to do this, because otherwise you just don't succeed. Our job is to make the customer happy that they bought the right thing.
Yep.
So the way you do that is they buy the product, they install it, then you run into an issue. They call you up and they say, I have issues doing such and such. And the job of support at that point is to make it right. And not to say, oh, you have a network problem, go talk to your network guy.
Exactly.
So, and the case that you mentioned in your example would be one of them. So if somebody actually is stressing the network and they call up with that issue, we would look at it and we say, oh yeah, you have stressed your network, and you should, here's a white paper that describes best practices, and we recommend that you move to this configuration because it will make it just better. And so, in a sense, the support team became a team that would support the SAN for the customer, with the goal of making the customer's experience with our product very successful.
Yeah, and I think that's kind of been evident in EqualLogic's reputation with customers. Kind of wrapping up, taking that customer experience, the ease of design, and or the ease of implementation, and maintaining these things. Where do you guys kind of see EqualLogic going next? What hard problems, or sometimes the easiest problems, or the hardest ones to solve? Where are you guys kind of taking this next?
Well, we listen. We obviously spend a lot of time listening to our customers, and just the other day we had a conversation with some of them, and a couple of their messages were that a lot of what they're looking for is to keep doing the things we did very well. So they said ease of use is your claim to fame.
Yep.
Don't ever lose that. The other one is keep innovating. If you slow down, if you stop, somebody behind you runs you off. So you can't do that. So what specifically would that mean? I think it could mean everything. Obviously, it means adapting to larger disk drives, higher speed networks, and what all that implies. And the implications aren't always terribly obvious. For instance, if you have larger disk drives, it means you have larger RAID sets, which means you have to think about how you're going to deal with RAID rebuilds in a scenario like that. And we've done a bunch of work in that area already, and we'll continue to look at that. Another example would be people have, in the past we've built block storage arrays, and people would separately deploy file servers. As you know, about a year ago we introduced the FL7500, which basically is a physically separate file server, but the management of it is packaged with the management of EqualLogic storage group, so that it becomes a single integrated file and block service. But it's physically separate hardware components. So you can see so that's our first step in an integrated block and file service, and we'll continue to make further steps in that direction. Another thing that the industry is looking at, and is how to deal better with data compression. And as you know, Dell acquired Ocarina sometime in the past. It's a company that specializes in implementation and compression. And so obviously you might foresee that technology will make its way into Dell storage systems.
Yeah, I think that's all very exciting, and you know, even the blade array announcement was pretty exciting stuff. So, but that's about all we have time for. Really appreciate your time, and hopefully we'll get to talk to you again soon.
Very good.
Thank
Glad
you.
to be here.